In this last video of our preparing for calculus with analytic geometry series, we are going to cover some trigonometry topics with special right triangles, 30, 60, 90 right triangles, 45, 45, 90 right triangles, 3, 4, 5 right triangles, 5, 12, 13, so on and so forth, some special right triangles. We'll get there. The unit circle, some trigonometric identities, and solving for when your equation involves a variable that's an angle. You may have sets of answers that come in a pattern because of the wavelength and frequency of sinusoidal functions. So let's go ahead and get started. We want to find the exact value of sine of angle A and cosine of angle A in the first problem. Remember that your sine of your angle is going to be equal to your opposite side divided by your hypotenuse, and your cosine of your angle is going to be your adjacent side divided by your hypotenuse. Angle A is in the upper left-hand corner here. So the opposite side to angle A is going to be 48. The hypotenuse is going to be 60. We're going to reduce here. This is going to be, let me just take out a 4 is the first thing that I see. I'm going to reduce some more, and this is going to be 4 divided by 5. This is a 3, 4, 5 right triangle. I just didn't see the scaling factor off the top of my head. The cosine of angle A, because this is 4 over 5, is going to end up to be 3 over 5. But I'll prove that to you. This is going to be 36 over 60 is going to be, I'm going to take 6 away first, 6 out of 10. It's going to be 3 out of 5. So there we go. 3, 4, 5 right triangle is one of our special right triangles. Sometimes you see that it's been scaled that way. Everything was multiplied by 12, that this side was 3 times 12, this side was 4 times 12, and this side was 5 times 12, but there's your 3, 4, 5 special right triangle ratio. We're going to deal with that one a lot as well as a 5, 12, 13, 7, 24, 25, 18, 15, 17, and so on. So there's some Pythagorean triples that you'll want to go back and study. Now we want to find secant and cosecant. Secant of angle A and cosecant of angle A. So secant of angle A is going to be the hypotenuse divided by the adjacent side. Angle A is in the lower right-hand corner, so the adjacent side is going to be 16. This is going to be 34 over the opposite side of 30. I'm going to reduce this. This is going to be 17 over 8, and this is going to be 17 over 15. Again, this is an 8, 15, 17. This is 2 times 8. This is 2 times 15. This is 2 times 17. So one of those other special Pythagorean triples that we just talked about. Now we've got, this is definitely a 3, 4, 5 right triangle. This is 9, 12, 15. This is 3 times 3, 3 times 4, 3 times 5. We want the sine of angle A is going to be, and A is in the upper left-hand corner. The ratio is going to be 4 to 5. The 3's are going to cancel off. The tangent of angle A is going to be opposite over adjacent is going to be 4 to 3 because these 3's are going to cancel off. If the sine of theta, I'll put theta in my lower left-hand corner here. Sine is 2 to 3. Find secant of theta. So we're going to use the Pythagorean theorem to say that x squared plus 4 is equal to 9, x squared is equal to 5, x is equal to the square root of 5. So our secant of theta is going to be 3 hypotenuse divided by adjacent root 5, but I need to rationalize that. So that's going to be 3 root 5 over 5. Now we're going to find the cosine of theta. If secant of theta is equal to 6, well, they're reciprocals of one another. So that means that the cosine of theta is going to be 1/6. That's easy enough. If cosine of alpha is equal to root 7 over 4, find secant of alpha. Well, secant of alpha is going to be the reciprocal, 4 over root 7, and we're going to rationalize that. That's going to be 4 root 7 over 7. Now we're going to have if sine of theta is equal to root 11 over 6, cosine of theta is equal to 5 over 6, and tangent of theta is equal to root 11 over 5, find cosecant, secant, and cotangent. So cosecant of theta is the reciprocal of sine of theta. It's going to be 6 over root 11. We're going to rationalize that, and that's going to be 6 root 11 over 11. The secant of theta is the reciprocal of the cosine of theta. So that's going to be 6 over 5. And the cotangent of theta is going to be the reciprocal of the tangent of theta, is going to be 5 over root 11, which we're going to rationalize. It's going to be 5 root 11 over 11. Remember that sine and cosine must stay between -1 and 1. Tangent and cotangent can take on any values from -infinity to infinity. We'll look at those graphs in a little bit. Now we've got some special right triangles that we're going to look at here. There's our 30-degree angle, our 60-degree angle, our 90-degree angle, and they're in ratios of the short side across from the 30-degree angle is going to have a ratio of 1. The long leg across from the 60-degree angle is going to have a ratio of root 3. And the longest side, the hypotenuse across from the 90-degree angle, is going to be twice as long as the short side. This is a 30, 60, 90 right triangle. So the sine of 30 degrees is going to be 1/2. The cosine of 60 degrees is also going to be 1/2 because these are cofunctions and complementary angles. So you're going to see that the cofunctions of complementary angles are going to be equal to the same thing. That was 8 and 10. I'm going to do number 9 here. The cosine of 30 degrees is going to be root 3 over 2, and that's going to be the same thing as the sine of 60 degrees is also going to be root 3 over 2. Now we're going to go on to number 12. Yes. And the tangent of 60 degrees is going to be opposite over adjacent. So that's root 3 over 1 is root 3. I'm going to jump to number 17. So we stick with this 30, 60, 90. The secant of 30 degrees. So bear with me, I'm going out of order, but secant of 30 degrees is hypotenuse over adjacent. And we're going to rationalize that. So the secant of 30 degrees is going to be 2 root 3 over 3. Now that I'm finished with that triangle, I'm going to come back and do the 45, 45, 90 right triangle with all of these things with 45 degrees in them. So 45, 45, 90 right triangle is an isosceles right triangle, meaning that I didn't draw it very well. Let me go back and draw it again. Best of my ability. That's better. Not great, but better. So this leg and this leg should be the same length. 45, 45, 90. So this is a ratio of 1 to 1, and that makes that the square root of 2. So when we have, starting with number 13, the tangent of 45 degrees, it's opposite over adjacent, doesn't matter which 45-degree angle I pick, it's the same answer, is a ratio of 1. The cotangent of 45 degrees is just the reciprocal of 1 is also 1. The secant of 45 degrees is going to be hypotenuse over adjacent is going to be the square root of 2. And the cosecant of 45 degrees is going to be hypotenuse over opposite, which is also going to be the square root of 2. We already did number 17 the last set with the 30, 60, 90. So let's just summarize again. 30, 60, 90. I call this angle A, B, C for a second. So we've got sine 30, cosine 30, tangent 30. Let's just make a table here. Zero degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, sine, cosine, tangent, cosecant, secant, cotangent. Okay, just write it in a table like this. So sine of 0 is 0, cosine of 0 is 1, tangent of 0 is 0, cosecant of 0 is undefined, secant of 0 is 1, cotangent of 0 is undefined. Sine of 30 was 1/2, cosine of 30 was √3/2, tangent of 30 is √3/3, cosecant is 2, this is 2√3/3 for the secant, and cotangent is going to be √3. For 45 degrees, cosine and sine are both 1. I'm sorry, 1/√2. We're rationalizing here, so this is √2/2. √2/2. Tangent is 1. Cosecant is √2. Secant is √2. Cotangent is 1. For 60 degrees, sine and cosine flip places. Tangent is going to be √3. And this is √3/3 over here. Reciprocal of the, this is 2√3/3, and this is 2. These all switch places here. Okay, and now for 90 degrees, the sine is 1, the cosine is 0, the tangent is undefined, cosecant is the reciprocal of sine, reciprocal of 1 is 1, reciprocal of 0, undefined, cotangent is going to be cosine over sine, that's going to be 0. So these are going to be important. We're going to express them on the unit circle. You can remember these triangles, but we're going to mostly be looking at a unit circle for them, and I don't think we actually look at the unit circle here, so let me quickly draw that here, just the first quadrant. If you use your left hand, this can help you. There's points here that are going to be cosine, sine of the angles that we just talked about. So this is going to be √3/2, 1/2 for 30 degrees. This point over here is 1, 0. This is √2/2, √2/2. This is 1/2 √3/2. And this is 0, 1. Okay. We'll come back to that unit circle idea in a little bit. They just reflect into different quadrants. So we'll start talking about reference angles, and that's what I'm talking about. Find the exact acute angle. Acute means that it's in quadrant 1 that I just drew, where the sine is √3/2. So sine is √3/2. This is going to be a 60-degree angle. Tangent is going to be √3. This is √3/1. This is also the 60-degree angle. Cosine is √2/2. That's the same as 1/√2. Cosine, that's 45 degrees. Tangent is √3/3. It's the same thing as 1/√3. So tangent is 1/√3. That's going to be a 30-degree angle. Cosecant is √2, which means that sine is 1/√2. So if sine is 1/√2, that's a 45-degree angle. Cotangent is 1, which is the same thing as tangent being 1. Ratio of 1 to 1, that's a 45-degree angle. And my secant is √2, which means my cosine is 1/√2. That's a 45-degree angle. I've done everything in degrees, but you also want to get used to giving answers in radians, which we'll get to in just a second. My cotangent of theta is √3. That means that my tangent of theta was 1/√3. So 1/√3, that's a 30-degree angle here. My cosecant of theta was 2. That means that my sine of theta was 1/2. That's a 30-degree angle. And if my secant of theta was 2, then that means that my cosine of theta was 1/2. 1, 2, it's going to be √3. This is my 60-degree angle here. Find the measures of two angles, one positive and one negative, that are coterminal with the given angle. So coterminal with 40 degrees. 40 degrees is up here in quadrant 1. Here's 40 degrees. I could go all the way around again, another 360 degrees. So this would also be 400 degrees. Or I could come counterclockwise like this, negative 360 degrees. So that would be negative 320 degrees. Now we have negative 19 degrees, somewhere down here, negative 19 degrees. And we're going to say 360 added to a negative 19 is going to give us 341 degrees if I go all the way around. Or I could subtract 360, and that would give me a negative 379. Use the information given to find which quadrant the angle is in. So I'm going to remember that all students take calculus. That's how I remember this. Or some students say add sugar to coffee. Something like that, that all 6 trig functions are positive in quadrant 1. Sine and its reciprocal are positive in quadrant 2. Everything else is negative. Tangent and its reciprocal are positive in quadrant 3, everything else is negative. Cosine and its reciprocal are positive in quadrant 4, everything else is negative. So if I have a positive tangent, that's positive slope, so I'm in quadrant 1 or 3, and sine is negative, that's a negative y value, I'm in quadrant 3. 34, cotangent, that's still related to my slope, but it's x over y instead of y over x, is negative, I'm here. And cosine is positive, that's a positive x value, I'm in quadrant 4. 30, sorry, these were wrong numbers here. 30, 31, and this is going to be 32. Tangent is negative, so I have negative slope, and sine is negative. My y value is negative, so I'm in quadrant 4. Okay. Now I'm on to number 33. Find the trigonometric function value of the angle shown. So I've gone all the way around. This is a 3, 4, 5 right triangle in quadrant 2. So I'm in quadrant 2, -3, +4, always a positive value for my hypotenuse. It asked me to find the sine of the angle. So the sine of my angle theta is going to be equal to 4/5. For number 34, my triangle is down here in quadrant 4, and they say that my x is 4, my y is -√33. And this is going to be 16 and 33, add to give me 49. This is a 7 over here, and they want the cosine of the angle. The cosine of this angle is going to be 4/7. $35 asks me for the secant of the angle. Got a triangle that is 7 in the x direction, 6 in the y direction, and I'm going to need to find the hypotenuse. 6 squared plus 7 squared is equal to my hypotenuse squared. 36 plus 49 is equal to x squared. This is 85. This is x squared. √85 is equal to x. So secant is going to be hypotenuse over adjacent. Now we have an angle that's in quadrant 3, and we have -3√2 for the x, -4 for the y. We're going to have to find the hypotenuse again. This is going to be 9 times 2 plus 16. 18 plus 16 is 34. This is √34. And we need the sine of the angle is going to be opposite over hypotenuse, which we're going to have to rationalize. Is going to be -4 √34/34. This is going to be 2. This is going to be 17. So that's -2 √34/17. On to number 37. We have a triangle down in quadrant 4 again, and it is 3 on the x and -√5 on the y. 9 plus 5 is 14, and we need to find the cosine of the angle. So that's going to be 3/√14. We're going to rationalize again. going to be 3 root 14 over 14. Always rationalize for right now because you don't know when you need to and when you don't need to. We'll get some more practice with that in calculus and figure out when nothing is going to cancel and you don't need to. Now we're going to use some identities to simplify some things. So cosine of x minus sine of x squared is going to be cosine squared minus 2 sine x cosine of x plus sine squared of x. Cosine squared plus sine squared going to be an identity. Two sine x cosine x, also an identity. So we're going to say this is 1 minus sine of 2x. Those are just straight off of your identities. Sine x minus cosine x times secant x plus cosecant x. Sine times secant can be sine over cosine is tangent. Sine times cosecant, those are reciprocals, that's 1. Minus cosine times secant, those are reciprocals, that's 1. Minus cosine over sine, that's cotangent. So those make a 0, and this is tangent minus cotangent. So let me see if I can do anything else with this. Nope, I don't think I can. Okay, just checking. 1 minus cosine times 1 plus cosine is going to be 1 minus cosine squared. It's a difference of squares. I'm not going to have a middle term. This is going to be the definition of sine squared from the Pythagorean identity that sine squared plus cosine squared is equal to 1. I can say that sine squared is equal to 1 minus cosine squared. Sine times secant tangent plus cosecant plus cotangent is going to be sine squared plus 1 plus cosine, and let's change everything into cosines because I've got a cosine here. So this is 1 minus cosine squared plus 1 plus cosine. So that is going to be a 2 plus cosine minus cosine squared. Factor out a -1 here. Cosine squared minus cosine minus 2 is going to be a negative cosine minus 2 cosine plus 1. I'd much rather have that in factored form like that, because my question is probably going to be, where is this thing equal to 0? So that's why I'm trying to simplify these things most of the time. It is, none of these answers here so far are wrong, but we don't like mixtures of sines and cosines if we can help it. So get it all into factored form if you can. Use basic identities to simplify the expression. 1 minus cosine, 1 plus cosine, plus cosine squared. This would be 1 minus cosine squared. plus cosine squared is going to be 1. We could also change that 1 minus cosine squared into a sine squared, and sine squared plus cosine squared would be 1. Cotangent squared minus the quantity cosecant minus 1 times cosecant plus 1 is going to be cotangent squared minus the quantity cosecant squared minus 1. 1 plus cotangent squared is equal to cosecant squared. So cosecant squared minus 1 is equal to cotangent squared. This is cotangent squared minus cotangent squared. That's 0. Tangent of theta minus secant of theta in parentheses times tangent of theta plus secant of theta is going to be tangent squared minus secant squared. I'm going to use the identity that secant squared is equal to 1 plus tangent squared. So it's tangent squared minus 1 minus tangent squared. And that's going to give me a -1 for an answer. Now we have tangent squared of theta plus 6 secant of theta minus 6 over secant theta minus 1. Watch out when you have these quadratics that this one without the exponent on it that's in the middle term is going to tell you what your quadratic has to be in terms of. So I'm going to have to change these tangent squareds into secant squareds by knowing that 1 plus tangent squared is equal to secant squared. So tangent squared is going to be equal to secant squared minus 1. So we're going to replace that tangent squared with secant squared minus 1 plus 6 secant theta minus 6 over secant theta minus 1. Going to combine our like terms of -1 and -6 to make a -7. 6 secant theta is in the middle. Secant squared is the first term. Now we're going to factor. And this is going to be secant of theta times another factor of secant of theta. We're going to have plus 7. We're going to have minus 1. We're going to have secant theta minus 1. Those factors will cancel as long as secant theta is not equal to 1. Secant theta can't be equal to 1, right? So there we go. There's lots of angles that would give us secant of theta is equal to 1. So we can't have any of those angles or we'd get an undefined 0 over 0. Factor and simplify. Number 46, 1 minus 2 sine squared of x plus sine to the 4th of x. I'm going to write it in descending order instead. It's going to be sine squared of x, sine squared of x, -1, -1. So this is going to be, both of those are going to be squared, right? Plus 1, minus 2. So this is going to be sine x plus 1 squared, sine x minus 1 squared. There we go. So now we have cosecant x times sine squared x plus cosine squared x tangent x over sine x plus cosine of x. So if I multiply through by cosecant, that's a 1 over sine in the top. That's a sine x plus a cosine x in the top. And that is sine x plus cosine of x in the bottom. And that equals 1, as long as it's not 0 over 0. We know that though. Now we have tan to the 4th x minus secant to the 4th x. This is going to be tan squared x minus secant squared x times tan squared x plus secant squared x. Tan squared minus secant squared is going to give me a -1 times tan squared plus secant squared is going to give me, let's see, let's just replace my tans with secants there. So that's a secant squared minus 1, secant squared minus 1 plus secant squared. That's at least going to give me only one trig function that's simpler. This can be 1 minus 2 secant squared x. I really could factor that if I wanted to into this and this, and I'd be done. I would really like that. I might like it better if I had gotten it all in terms of tangents, because tangents can be done with my calculator, but that's not bad. I have the option of up here changing secants to tangents or tangents to secants. So take your pick. That was number 48, I believe. Yes, on to number 49. Sine to the 4th of x minus cosine to the 4th of x plus cosine squared of x. So I'm going to get these sines to turn into cosines. So this is going to be 1 minus cosine squared, and that's squared because this is sine squared. So this is going to be 1 minus 2 cosine squared plus cosine to the 4th minus cosine to the 4th plus cosine squared is going to be, that's 0. It's going to be 1 minus cosine squared, and 1 minus cosine squared, that's sine squared. So we've simplified it. Cosine to the 3rd x minus 512. That looks like that might be a difference of cubes formula that they want us to use. Let's go ahead and just make sure. Math cube root of 512 is going to be 8. So we have cosine of x minus 8 times cosine squared plus 8 cosine x plus 64. I think that's it. Let's see how we're going to get anything else out of that, but remember that this is a difference of cubes that you can factor. Now we're going to simplify 1 minus sine squared x over sine x minus cosecant x. I don't like that cosecant because it's got a divisor of sine, so I'm going to multiply everything by sine. Sine times 1 minus sine squared over sine squared minus 1. So these are opposites of one another that give me a -1, and I end up with negative sine. Cosine squared x plus 10 cosine of x plus 25 over cosine x plus 5. This is cosine of x plus 5 quantity squared over cosine of x plus 5. I'm going to just cancel one of those and end up with a cosine of x plus 5. Cosine to the 4th x minus sine to the 4th x over cosine squared x minus sine squared x. This is going to be cosine squared x plus sine squared x. Cosine squared x minus sine squared x, because it's the difference of squares, over cosine squared minus sine squared. Those go away. And I'm left with cosine squared plus sine squared, but that's equal to 1. Secant of negative x over tangent of negative x. Remember that secant is an even function, so secant of negative x is secant of x. Tangent is an odd function, so tangent of negative x is a negative tangent of x. If you need to, switch this so that it's in sines and cosines, so that you know what's going on. This is 1 over cosine divided by sine over cosine. So this is -1 over cosine times cosine over sine. Cosines are going to cancel. -1 over sine is going to be a negative cosecant. It's okay to change things into sines and cosines if you need to. Verify the identities. I really like these. These are some of my favorite problems. So sine x sine y is equal to cotangent y minus cotangent x. So we're going to start off with the more complicated side, and we're going to try and turn it into the simpler side. So I definitely see the left side is more complicated here. Our sum difference identity says that this is going to be sine x cosine y minus cosine x sine y over sine x sine y. We're not going to touch that left-hand side, just seeing if this is true. So now we're going to divide both of these factors. I'm just going to leave that right-hand side. I'm not going to keep writing it. Sine cancels out with sine there. Sine cancels out with sine there. Cosine of y over sine y minus cosine of x over sine x is going to give me cotangent of y minus cotangent of x, which is what my right-hand side said, and my identity has been established. Cosine of x minus y minus cosine of x plus y needs to equal 2 sine x sine y. So I'm just going to stack these over top of each other, the left-hand side. Cosine x cosine y plus sine x sine y minus, so this is cosine x cosine y, that's going to be negative, and then this normally would be positive. I'm sorry, this normally would be negative here, so it's going to become positive because of the subtraction. Sine x sine y, we're going to add them together, and we have 2 sine x sine y, and that's exactly what my right-hand side says it is. sine to the fourth sine of 4x. We need that to be 2 sine of 2x cosine of 2x. That's a pretty straightforward one. I just need to write this as 2 times 2x to start off with. And then my identity for sine 2 theta says it's 2 sine of theta cosine of theta. So that's also established. Cosine of 4x, we want to be 2 cosine squared of 2x minus 1. So that's another one that I rewrite this as a double angle. And we're going to use the double angle identity that's cosine squared. It says it's 2 cosine squared theta minus 1. So this is going to be 2 cosine squared of theta minus 1. Memorize those double angle identities, those power reducing formulas and things like that for your calculus class. You're really going to need them. All right, now we want sine of arc cotangent of x. I'm going to use a triangle to do this. So the angle whose cotangent is x. And so this means that this is 1 plus x squared. Inside here, the sine of that angle is going to be 1 over root 1 plus x squared. See how I did that? I just said if the cotangent is x, that means that it's x over 1 for my adjacent over my opposite for cotangent. Then I use the Pythagorean theorem to tell me that the hypotenuse had to be a squared plus b squared under the square root sign. And then I use that to say sine of the angle has to be an opposite over hypotenuse. Now I'm going to find the tangent of the arc cosine of u over 3. So if the cosine is u over 3, that makes this side over here 9 minus u squared. And that's by the Pythagorean theorem. The tangent of theta down here is going to be opposite over adjacent. We're on to number 62 already. 12 cosine of x minus 6, 8 cosine of x, and it's an equation now, it equals 0. So we're going to have to solve on 1 revolution around the circle is what our instructions say. I'm not sure if you can see that, but it says solve on the interval of 0 to 2 pi. 0 is included, 2 pi is not included. So we're going to say that 12 cosine of x minus 6 equals 0, or 8 cosine of x equals 0, means that 12 cosine of x equals 6, or cosine of x equals 0, cosine of x equals 1/2, or cosine of x equals 0. Let's think about our unit circle, because we need cosine to be positive or 0. So cosine is 0 at pi over 2. Does it say? Yeah, it says to answer in radians because it says 0 to pi over 2. So pi over 2 or 3 pi over 2. Now we need cosine is going to be 1/2. So that's going to be at pi over 3 or 5, 2, 3, 4, yeah, 5 pi over 3. Let's go ahead and let's look at those triangles so that you understand what I'm saying. Then I need cosine to be 1/2, so the x value needs to be positive here. Root 3, root 3. This is my 60-degree reference angle, which is in radians pi over 3. This would be negative pi over 3, but it doesn't tell me that I'm allowed to have negative angles. So I'm going to have to go 2 pi minus pi over 3. Be 6 pi minus pi over 3 is 5 pi over 3. So This all the way around here is 5 pi over 3. Cosine is related to my x value. So if x is 0, I'm at this point 0, 1, or at this point down here is 0, -1. 0, 1 is at pi over 2, 90 degrees. 0, -1 is at 3 pi over 2, or 270 degrees. So those are my answers. My answers from smallest to biggest are pi over 3, pi over 2, 3 pi over 2, 5 pi over 3. Now we want to solve 3 sine squared x minus 6 sine of x plus 4 is equal to 1. I'm going to subtract that 1 from both sides. 3 sine squared x minus 6 sine of x plus 3 is equal to 0. Factor out the 3, divide it out because it's not going to affect the zeros. Sine squared of x minus 2 sine of x plus 1 is equal to 0. Now we're going to factor sine of x equals 0. These are both a -1. So I only need to solve it once. Sine x minus 1 equals 0. Sine x equals 1. So I need my y value to be 1. There's only one place where the y value is 1. That's at 90 degrees. That's x equals pi over 2 in radians. Cosine of 2x is equal to root 2 over 2. All right, so I'm gonna show you the way that I like to do this. If x has to be an element of 0 to 2 pi, then that means that 2x has to be an element of 0 to 4 pi. I'm just going to double my interval here to start off with. And I'm going to think of all of the answers between 0 and 4 pi that satisfy this. So 2x is going to be equal to, let's see, so I could have pi over 4. Sorry, this is my first answer. Pi over 4. Or I could get all the way around to 7 pi over 4. Or I could come around all the way again to 9 pi over 4. Or I could add here, this would be 15 pi over 4. That's going to be on 2 revolutions. So x is going to be equal to pi over 8, or 7 pi over 8, or 9 pi over 8, or 15 pi over 8, and those are going to keep me between 0 and 2 pi. These are very difficult to start off with. I just knew that the cosine was positive in a 45-degree reference angle in quadrants 1 and 4. So I picked the first time I got to quadrant 1, this first time I got to quadrant 4, the second time I got to quadrant 1, the second time I got to quadrant 4, because of this multiplier of 2. When I was going around, and then I divided everything by 2, and I was good. 2 cosine of x plus 1 is equal to 0. So 2 cosine of x is equal to -1. Cosine of x is equal to -1/2. This is a lot easier. We're here, -1, 2. So cosine, excuse me. So we're over here for both of them. -1, 2. So we're going to have a reference angle of pi/3 above or below the negative x-axis. That is going to give me that x is 2 pi/3 or 4 pi/3, because the x-axis is 3 pi/3 over here. This is pi, which is 3 pi/3. We've got to be a pi/3 above or a pi/3 below. Number 66, 2 sine squared of x is equal to sine of x. We never divide by the trig function unless we're dividing to get sine over cosine as tangent, because then we're not really getting rid of anything. We're always going to subtract, and then we're going to factor. Sine of x, 2 sine of x minus 1. So sine of x equals 0, or 2 sine x minus 1 equals 0. Keep that. 2 sine x equals 1. Sine x equals 1/2. We are still stuck on the first revolution. So y is 0 when x is equal to 0 or pi. Sine is 1/2 at pi/6, and 5 pi/6. We're in quadrant 1 or 2 because sine is positive. So let's put these in order. 0, pi/6, 5 pi/6, pi. Those are my 4 answers. Sine squared x minus cosine squared x is equal to 0. Let's go ahead and change this into cosine squared minus sine squared is cosine of 2 theta. So this is negative cosine of 2x is equal to 0, which means that cosine of 2x is equal to 0. So cosine of 2x, that means that 2x is going to be equal to, let's see, zeros of cosine happen at pi/2, 3 pi/2. Then I'm going to have 5 pi/2 and 7 pi/2. So that's x is pi/4, 3 pi/4, 5 pi/4, 7 pi/4. That's my solution set. There we go. I think we're done now. That was it. So hope that gave you a good review of some trig identities, some special right triangles, and things like that that we're going to use in calculus with analytic geometry. You're also going to need to know some about the repetition, the cycles of sine and cosine and tangent and things like that to write some generic solutions in terms of either K or N, however your teacher tells you to do it. So if, for instance, I said that I started off with an equation that said sine of theta equals 1/2, and I told you to find all solutions everywhere for theta, theta would have to be an element of the set of pi/6 is the first place that it's 1/2, plus or minus 2k pi union the set. Now the next one is 5 pi/6 plus or minus 2k pi, and I would let you know that k is an element of the integers. that it can be positive or negative. I'm going 4 revolutions around the circle because the period of sine is 2 pi. If I have one of those questions like this one, let me go back and do this one. Cosine of 2x is equal to root 2 over 2. Then I'm going to say that 2x is an element of the set, and I'm going to start with the first time it's root 2 over 2 is pi over 4 plus, and the period of cosine is 2k pi union. The second time is going to be 7 pi over 4 plus 2k pi. And then those are my only 2 sets. I'm going 4 revolutions around. So then when I get x, x is going to be an element of, I'm going to divide everything by 2, pi over 8 plus 2 divided by 2 is 1, k pi union 7 pi over 8 plus k pi. Sometimes with tangent, when you do these, the 2 sets will come out to be the same set. You need to watch out for that with tangent and cotangent. Doesn't happen with sine and cosine because they're not 180 degrees away from one another. So that is a general solution. That's the only thing that we didn't do that I would watch out for and that I would practice. Your teacher may use n's instead of k's. It's the same thing. And again, you need to specify that k is an integer that can be positive or negative here if you're trying to get general solutions. Okay. Thank you, and have a good day. Ask me if you have questions in the Discord, or if you are a Reynolds Community College student, come see me with questions in Math Central Plus.